Hello students, today we will see electric circuit, electric field and the direction of electric current. In the nature, it is observed that there are two types of charges, positive charge and a negative charge. Positive charge is present on a positively charged particles, they are called as protons, and the negative charge exists around the particles called as electrons. Electrons are considered to be considered as a cloud of a negative charge. So there are two types of charges, positive charge and a negative charge, and it is observed that these two charges exert force on each other. For example, a positive charge and a negative charge attract, and a negative charge and a negative charge repels, and two positive charges repel each other, and a positive charge and a negative charge attract each other. So let us see, suppose this is the symbol for a positive charge and this is a symbol for a negative charge, and now these two charges attract each other. Now it is observed that these two charges attract each other, or it is observed that these charges have a force which exists around them, and this force exists in the form of lines. So positive charge and a negative charge has a force around it, and this force is considered to be in the form of a lines. Now, so therefore a positive charge will get attracted towards a negative charge, and the line along which a positive charge and a negative charge get attracted towards each other is called as a line of a force. So electric field is a region where there are lots of magnetic electric lines of forces. So this is an electric field. So electric field is a region where a force of electrostatic or it is a region in which electrostatic force of attraction or repulsion can be experienced. So here a positive charge and a negative charge attracts each other, and Benjamin Franklin had given a direction to this, and this direction is from the positive charge to the negative charge. So it was considered that these electric field lines have a direction, and these electric field lines have a direction in which it was decided by Benjamin Franklin that the magnetic lines of electrostatic lines of forces, they emerge out of a positive charge and they go towards the negative charge. So electric field is the region in which electrostatic force can be experienced, and electric field exists in the form of electric field lines, and electric field lines or we can say electric field line is a region where electrostatic force of attraction can be experienced. So here we can see a electric field which starts from a positive charge and a negative charge. So now let us see a simple electric circuit. So suppose if you have a bulb and connect to a battery or a cell, and here we see that as soon as we switch on the current, the electric current flows from a positive charge to a negative charge. Now this is a simple electric circuit in which we see that if you switch on the current, electric current flows from a positive charge to a negative charge. So here the direction of current is considered to be a positive charge and a negative charge because it is the direction of electric field. Direction of electric field was decided quite earlier, at least approximately 150 years back. It was decided the direction of electric field will be always from positive to negative, and therefore direction of conventional current is also considered to be from positive to negative. Okay, whereas electrons always travel from a negative terminal towards the positive terminal. Electrons always travel from a negative terminal to the positive terminal. Electrons are situated on a negative terminal of a cell or a battery, and negative terminal is a region where there is a majority of electrons, and positive terminal is a terminal or it is a place where there is deficiency of electron, and therefore electrons always have a tendency that they always move from a surplus region to a deficient region, and therefore electrons move from a negative terminal to the positive terminal, and that constitutes an electronic current. So conventional current is a direction of an electric field, and electronic current is the actual direction of motion of electron, which is from a negative terminal to the positive terminal. So students, don't confuse between between a conventional current and a electronic current. Conventional current is similar to the direction of electric field, whereas electronic current is the actual motion of electron which starts from a negative terminal to the positive terminal. Now let us see what is an electric current. We have already seen the direction of a conventional current. Conventional current flows from positive terminal to the negative terminal, and electronic current flows from a negative terminal to the positive terminal. Conventional current is a direction of a electric field, whereas electronic current is the actual direction of the flow of electrons from a negative terminal to the positive terminal. We have also seen what is an electric circuit. Electric circuit is the path along which an electric current can flow. So what can become a electric circuit? Any conductor through which electric current can flow can become a electric circuit. So electric circuit is simple, is in a very simple words can be said that it is a path along which electric current can flow. So electric current can flow through all metals. So all metals or conductors are considered to be the electric circuit. Now electric circuit is made up of different elements we have already seen, like a switch, bulb, battery, and all these are all components of an electric circuit. So let us come back to the electric current. So electric current is defined as a rate of flow of a charge through a cross section of a conductor. So electric current is a flow of a charge through a cross section of a conductor. Now there are many physical quantities in the physics. They are called as a rate quantities. So electric current is also a rate quantity which tells us rate of flow of a charge. So how many charges will pass through a cross section in 1 second. It is not how much electrons pass from this end to this end. It is not. It is electric current is how many coulombs can pass through a cross section of a conductor. So electric current is a rate quantity, and in the same way there are different rate quantities in physics, like speed is a rate quantity, rate of change of distance. Velocity is a rate quantity, rate of change of displacement. Acceleration is a rate quantity, rate of change of velocity. And just like that, power is also a rate quantity which says that it is power is a rate of expenditure of energy. So in the same way, electric current is the rate, or this is the amount of charges which pass through a cross section of a conductor. So electric current can be represented with the symbol I. Q is the symbol for charge and T is the symbol for time. So current is charge upon time. So it is 1 ampere of a current is defined as if a 1 coulomb of charge pass through a cross section of a conductor in 1 second, then we can say the electric current flowing through the circuit is 1 ampere. So 1 ampere is the 1 coulomb of charge. It is 1 coulomb of charge passing through a cross section of a conductor. And what is 1 coulomb? 1 coulomb is a packet, or it is a collection of 6.25 into 10 raised to 18 electrons. So 1 coulomb is nothing but a collection of 6.25 into 10 raised to 18 electron. So if 6.25 into 10 raised to 18 electron pass through a cross section of a conductor in 1 second, then we can say that the electric current flowing through the cross section of a conductor is 1 ampere. Electric current can be measured with an instrument called as ammeter. So ammeter is an instrument which measures the electric current. So 1 ampere is considered to be 1000 milliamperes. 1 ampere is 1000 milliamperes, or 1 milliampere is equal to 10 raised to minus 3 amperes. Students, please remember the relation. 1 ampere is 1000 milliamperes, or 1 ampere is 10 raised to minus 3 amperes. So once again we will recap that electric current is a rate of flow of a charge, and electric current is measured in an instrument with the help of instrument called as ammeter, and ammeter is always connected in the series. For example, if this is a simple circuit, then ammeter is always connected in series. Positive of ammeter is connected to the positive of a cell or a battery, and negative of ammeter is connected to a negative of the battery or a